Right. You jammy dodgers. This is mainly just to test out the new things, but also I'm going to explain this beauty to you. Yes, because I know you all want to know. Right. 1 plus 2 plus 3 plus 4, etc. It is infinity. Sigma n equals 1 n scaling to infinity. That is the question that we want to answer. So, am I able to increase the size of this? I'm not, okay. So, how do we tackle this? Well, generally we use this. We use 1 plus x squared plus x cubed plus x to the 4 plus x to the 5. And that equals 1 over 1 minus x. 1 over 1 minus x. And we do this in these steps. So firstly, this. We have to define this function as s so that we can manipulate it in algebra. Now we multiply x, so we multiply the 1 by x to get x, multiply the x by x to get x squared, going on, so x cubed, x to the 4. And now we can see that s multiplied by x equals s minus 1. If you see this bit, oh, my cat's meowing. Hello, girl. Hello, girl. So s multiplied by x equals s minus 1. So rearrange 1 equals s minus sx, and then factorize 1 equals s, brackets 1 minus x, so s equals 1 over 1 minus x. Now that we've got this out, we have here. Now we want to differentiate. Now differentiate, it is dy over d, that's a really bad d, dx, yes, of f of x, yes. Beautiful. So, how do we go about doing it? Well, for each term in this, we have to take 4 x to the n dy over dx is n multiplied by x to the power of n minus 1. So, for each term, we have, for example, 1. 1 is basically just x to the 0. So that is just completely removed because it's 0 multiplied by x to the minus 1. For x, we have it's just x to the 1, so it's 1 multiplied by x. No, it's not. It's 1 multiplied by x to the 0, which is just 1. Now for x squared, this is where it... Yeah, I put n. I put n instead of 2. Okay, let's remove that and replace it with a 2. There we go. For x squared, well, n equals x. X to the n. So n... And now nx... n minus 1. That was... Look at that writing. Ah. So it ends up with 2 x to the 1. You see? So you apply that to every single word, part of the polynomial, term of the polynomial, yes, and you'll get this, 1 plus 2x plus 3x squared plus 4x cubed plus 5x to the 4. But now, the reciprocal rule. This is, okay, so for f of x, if f of x equals 1 over g of x, so that basically means if a function of x, this is a polynomial, for example this is a function of x right here. So if f of x equals 1 over g of x is a reciprocal of another function of x, because 1 minus x is a function of x. You see. So if f of x equals 1 over g of x, then f dash, that just means derivative, so the result from differentiating of x equals negative g of x, yep, it's g of x, g dash of x, the derivative of the second function, over g of x squared. Now, why? It's the product rule and the chain rule, so yeah, don't worry about that one, laddos. So negative derivative g of x over g of x squared. Now, how does this work out? We have f of x equals 1 over 1 minus x. So g of x equals, oopsies, equals 1 minus x. Yes, okay. So, derivative of that, we do each term. So, it's left with, because the 1 is removed, negative x is just negative x, is negative 1. But since it's negative derivative, that means you just get 1. And over what? Well, it's just g of x squared, so 1 minus x, g of x squared. That was brilliant too again. Yay! Now, we have defined this, the derivative. So, if x equals minus 1, we just get 1, take 2, plus 3, yeah, we get this. This is only important the last stage. Now, I'm going to introduce the Riemann zeta function. This was made by, you guessed it, Riemann, but it's highly speculated by many other mathematicians. I'll go over a bit of speculation at the end of the video, lads. You better watch on. Yes, so I'm not very good at drawing zetas, so let's just do that. Let's just pretend that is zeta. So zeta s equals 1 over 1 to the s plus 1 over 2 to the s plus 1 over 3 to the s, going on. Now, why is it important to have this form? This reciprocal, that's the word. It's important to have the reciprocal, because as you can, if you can see over here, we use negative 1. Negative 1. So we need to take s to be equal to negative 1 as well, because that's how algebra works. S essentially equals x in this example. So that is why we have to use the reciprocal. So we got the Riemann zeta function. Now we have to multiply it by 2 to the power of negative s. What does this do? Remember that. Wait, did I do it wrong? I think I did something wrong. Wait. No, I don't think I did. Wait. No, I didn't. Multiplying it by 2 to the minus s, so that's essentially just flipping it over and, yeah, doing some dirty business with it. So you're left with 2 to the minus s plus 4 minus s. Yeah, you're just, that goes on and on and on and stuff. So now, getting to the sexy bit. So 1 minus 2 times 2 to the minus s zeta. God, zeta. Let's just pretend that that's a zeta. Zeta s. What is this? Well, it's a bracket. So multiply out the brackets, we get zeta s, which is, if you flip around the thingies, you just get 1. So it's 2 plus, God, minus s plus 3 to the minus s plus 4 to the minus s, going from infinity. Because this is these two. So that they're 1. The first thing we have to consider. I should use a different colour. Ooh, let's use a different colour. Ooh, look. Ooh, yes. Oh, that's pretty. It's brilliant. Right, lovely. So this is 1. This is what we have to first consider, because we're able to flip around the fraction and just make it a negative power. Now, 2. Let's use a different colour for this. Ooh, look at this. Ooh. Okay, 2. We have to do 2 times 2 to the minus s. So this, and then these two here. 2. So 2 is minus 2 times what we had earlier. 2 to the minus s plus 4 to the minus s plus 6 dot dot dot. Now, that looked amazing. You know what, I might just type it in. You know what? So. Oh look, I'm typing it in now. Oh, look. Comic Sans. Wait, does it have Comic Sans? Yes, it does. Top. Okay, so we have 1, let's just say 1 plus 2 plus 3 plus 4. And assume that we know that there are things. Okay, this, yeah. We also have negative 2, 2 plus 4 plus 6 plus 8. Now, what are we doing here? So if we move it here, and we do some clever things, it's just, oh god, I did the wrong thing again. Why do I always do this? Okay, make this bracket, there we go. Okay, now we can see. We can compare the two. Look, we have these two aligned. These I've done the wrong thing. Again, these two aligned. These two aligned. These two aligned. It's negative 2 multiply these. So, you can just write that as 1 take 2 plus 3 take 4 plus 5 take 6. Because it's subtracting 2 of it, which is... And since it's an infinite sequence, it goes on for infinity. Okay, I'm not gonna... dot dot dot. dot dot dot. Yeah, it goes on from infinity. So you're able to do that stuffs. Now, what do we have to do? We have to define s. Now, as you can notice, we have loads of negative s's. Loads of them. So, what do we do with negative s's? Set them equal to -1. So we just eradicate them completely. So we get 1, oops, I'm on the select tool. 1 take 2 times 2 multiplied. Oh my god, I did that too big. I'm going to reduce the size of that. 1 take 2 times 2. 1, that's a 1. 1 plus 2 plus 3 plus 4 dot dot dot. Bracket. So this is our initial question, this is just a bit added on. And we know that that equals 1 take 2 plus 3 take 4 plus, that's a plus, 5. God damn it. I'm really good at this. I'm really good at this whole paint thing. Hey, what do we notice? This is basically that thing over here. Over here, look. If you look, it's like exactly the same thing, right? So, we continue. So let's just sort of fix what's in the brackets. 1 take 2 times 2 is just -3. If you don't believe me, do the bidmass yourself. Well, PEMDAS, bidmass, bodmass, whatever you sodding want. -3 multiplied by our initial sum. 1 plus 2 plus 3 plus 4, going on from infinity, equals... Well, what did we define this as earlier? A quarter. And I didn't show you why we defined it as a quarter, so I'll do that now. This is equals a quarter because, reasons, because algebra. 1 over 1 minus x squared, x equals 1, so 1 over 1 minus x squared, that's x equals -1, sorry, 2, yeah, squared, yeah, so, yeah, that's fairly self-explanatory, but, you know, there are some smegheads. So, equals 1 over 4, and, hey, oh, guess what, multiply out the 3, so 1 plus 2 plus 3 equals -1 over 12, which happens to be minus 0.083 recurring. See, it's not that hard if you just go through step by step, understanding exactly what you're doing, and then poof, you've got the answer. Now, wait, what was I going to do? Oh yes, the special speculation thing. I mentioned this. This is I Easter egg this. The maths thing. Right, you have Riemann. 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 Right. What did Riemann say S was? Because he made up S. He made it up. What did I say it was? He'd say it was. Now this really doesn't matter. None of this matters, but it's just random, boring, fun stuff. Riemann said S is real. What's a real number? It's just the number that you see every now and then. It's this is what it's called. This is what it's called. It's that. It's that. That's a natural number. It's yeah. This includes numbers, all the numbers that we know, apart from numbers which are defined by I. Ooh, I. What is I? I is a complex number. It's an imaginary number. I think that's imaginary. Oh wait, I'll look it up. Number sets. Let's have a look. Let's have a look. Okay, we have natural numbers. Yep. Oh wait, did I accidentally do something wrong? Oops, I did something wrong. No, of course, I said natural numbers instead of real numbers. Oh no, it's wrong. It's actually this. Oh my god, I did it wrong again. You draw the second line after. Sorry, lads. Sorry, ladderinos. There we go. And oof, that's the real number. And did I get? Yeah, I did get the imaginary. That is the imaginary number. Yeah. Imaginary numbers are. Let's go on to. Okay. So real numbers are just everything. They're irrational numbers. They're natural numbers. All of the numbers that we know. Natural numbers are just 1, 2, 3, 4, 5, going from infinity. Real numbers is anywhere on the number line. So decimal points, negative numbers, irrational numbers such as pi and square root of 2, e. These are all real numbers. Euler, good old Euler. He was a special one. He said that S equals. I don't know which delta he. Okay, oh god. Euler S. I'll quickly check. Which Euler? What did he do? I don't know which one he used. Let's just say delta plus IT. I don't know which he. Delta plus IT. Now, what is delta plus IT? Delta and T are real numbers. Because delta is just a number, for example 1 or 2 or 2.5 or pi or square root of 2. T is also a real number, 1, 2, 3, square root of 2, pi, except you multiply I by t and you add that by delta. This is the common format for any imaginary, not imaginary, complex number, yes. And I is imaginary because it is the square root of -1, which is an undefined number. So basically the way you work, the way it's defined is I squared equals -1. I hope that you've all learned something in this this 18 minutes video. Very long video, but it's very informative video, so I hope you enjoyed, and if you didn't watch this through to the end, I'm going to kill you. The code is 321. Goodbye. Wait, I'll give it a bit of time, and then I'll end it. 3, 5, 1.